Hey guys, welcome back to my channel. In the last tutorials, I explained you how to calculate this diffuser sizing. So all this diffuser, how to do the sizing for this diffuser. So today in this video, I'm going to explain you the ESP calculation. So there is one format here for ESP calculation, guys. I will show you. This is the one format. So for this project, how to calculate the ESP, I will show you here. So ESP is nothing but the external static pressure. So external static pressure is going to calculate for the critical path or the longest path. Okay. So here in this project, in this design, the longest path is start from here, and the longest path is this one. Okay. So we will do the calculation for ESP external static pressure for this route. That means the ESP calculation is nothing but why we are calculating for the longest route, because to select the fan, the selection for the fan which is inside this machine. So this machine will push the air from this point to until the last terminal. That means the each terminal, the nearest terminals is having the flow, the required flow. So the fan is designing or selecting based on this longest path. Okay, the maximum longest path. So I will show you how to design this, how to calculate this ESP for this real project. So first of all, what we will do, we have to do the naming for ESP. Okay, so first of all, let me copy this. Okay, and keep it here for ESP calculation. So before I start this ESP calculation, I would like to request you guys, please to subscribe my channel if you are still not subscribed, because I am explaining the project from beginning to end, and I am doing the calculation for the real time project. So let us start now. Let me remove this all this calculation. Okay, and all this text I am going to remove. Okay, just to keep this drawing looks nice, that's why I'm going to remove the unwanted text here from this drawing. Okay, so we'll do the naming here. First of all, tagging for each duct. So let me copy this. Okay, and I put it here. Double click to edit. I'm going to do the one. Okay, so one is here flexible. Let me keep it move it inside the circle. Okay, okay, okay. So this is the point number one. Okay, flexible. And point number two is this one. Okay, contraction transition piece. And three is nothing but this duct, straight duct. So let me edit this one. This is the two. This is three. Okay, and this will be your four. Double edit. Okay, double click to edit, and this will be your point number five. Okay, and this will be your VCD 6, then straight duct 7, And then this is the transition phase 8, straight duct 9, then 10, again this straight duct up to here, this one 11, then shoe neck here 12, 13, 14, then VAV 16, 15, 16, then straight duct 17, then flexible 18, then this is the terminal 19. So this is your critical path. So for the critical path, first of all you do the tagging. So I already did here, let me edit 5, then here is 6, then 7, okay, and this is the 8, 9, 10. Move this 10, then this is your 11, move it inside 11, then here will be your 12, 12, and then copy this one 13, then here copy 14, let me remove this 14, and here will be your 15, then this is your 16, and this is your 17, 18, 19. This is the last point, which is 19. Okay, so up to here 19. Okay, so this is the critical path. So now we are going to start the calculation for external static pressure. So this time I'm going to use this acid duct fitting database software. So let me open that software. So here is your software. Let me open this. acid duct fitting database software. Okay, so this is your software. So first point, you can see here, let me this is the user input. So this is already designed for the previous project. So let me remove this, and this is your user input, and wherever this white box, I'm going to remove this. Okay, this is the user input. So all this is for the return. Let me remove this. Okay, okay, so all this remove. So I'm going to calculate for the supply, because in this project there is supply duct only, there is no return. So we will not calculate for the return duct. So we are going to only calculate for the supply. If there is return duct, so we have to calculate for the return as well, and for the fresh air also. Okay, there is fresh air. So in our case, our project only supply duct is there. So I'm going to calculate for the supply duct. Okay, so first fitting is flexible. So flexible, you can and comes under accessories, so I'm going to put it here. The quantity of the flexible is 1, and the pressure loss for the flexible we are considering 10 pascal. So just enter here the quantity, and I will get this pressure loss. Okay, remaining I'm going to remove. Okay, and second fitting is here, so I will remove this serial number, also tag number. So tag number 2 is nothing but the transition piece. Okay, transition. Okay, so what will be the size for this transition piece? That means the transition piece size is here. Here the machine mouth, and the size is 395 by 395. Okay, and this size is 40 inch by 40 inch, so 40 inch by 18 inch. That means you can convert here 395 by 395 and 40 inch by 18 inch, so convert into mm. So 40 to 25,000, so 1000 here. Okay, and here will be height will be 18 inch, so 18 inch will be 25 450 mm, and the length you have to check from this drawing. So DLI is the length command, so length will be 650. So here is your 650. Okay, and number of fitting is 1, so airflow will be 3500 cfm. Okay, so enter the airflow here in liter per second, so it will calculate in cfm. So 3500 divided by 2.119, 1651 lps, so 1651 liter per seconds. I am getting here 3498 cfm. So enter this value in the software here. Go to the software, and you can go to this common state, other smooth radius, then obstruction duct mode dampers. Go to this supply. Okay, and rectangular here, transition. Okay, and go to this pyramid. So this look like this, this fitting is look like this. Okay, this fitting is looks like this. This is your fitting. This from the machine enter like this, and it will go to this side. So this is your fitting. Okay, and you can found this fitting in HRA handbook, duct fitting database shop, duct fitting database, HRA handbook SA 62.1. You can found this also, this fitting, and the fitting number is SR4-2, transition pyramid supply air system, and this is taken from ASRA handbook 1986. Let me close this and enter the value here, HO and WO. So HO, this is your, let me zoom this. So this is your HO and WO. This is the bigger and this is the smaller. So let us enter here. WO is nothing but 1000 and HO is nothing but 450. This value 450 and 395 by 395. H1 W1 395 by 395, and length is 650, I think 650, and flow is 1651 liter per second. Simply calculate here, click on calculate, so you will get it here 40 pascal. So simply enter here the pressure loss, that is 40 pascal, and this is already here calculated by formula. So this apply by formula. So total pressure loss is nothing but the pressure loss into quantity, here number of fitting, that means only one. So next fitting is a straight duct, that means you can enter here straight duct. And the size of duct is 1000 by 450, 40 inch by 18 inch. Okay, so simply enter the size here, and the length of the duct you can calculate from this drawing. So from here to up to here, because there is one terminal here, that means the airflow will change from for this duct. So I am going to calculate up to here. That means here 2.8, 2.76 is nothing but 2.8 meter. So 2.8 meter I am going to consider. Okay, and the airflow is 1651. Okay, and the pressure loss I am you can calculate from here. Let me close this all straight duct. Okay, so I need this only, this pyramid and a straight duct. So here is your straight duct. Let me zoom for you. This is a straight duct. Okay, and this fitting is also taken from ASRA handbook 1948. So this fitting number is CR11-1, a straight duct rectangular. Okay, so this is H and W. H is nothing but the height, and W is nothing but the width of the duct, and L is nothing but the total length, and Q is airflow. So let me close this and just enter the value here. Okay, so H is nothing but 450, and width is nothing but 1000. Okay, and absolute roughness is nothing but 0.09. This is the roughness value for the GI sheet, so do not change this. Okay, and the length of the duct is 2.8 meter, and airflow is 2.8. Airflow is 1651 liter per second, so 1651 liter per second. And density, do not, you cannot change. Okay, and this value will be calculated by software. Velocity, pressure, friction factor, and pressure loss. So simply calculate here, click here on calculate. So the pressure loss in this duct is 0.6 pascal. So you simply enter here 0.6 pascal. And if you want to generate this report, simply click here, preview, print preview fitting. So this is your report. Okay, so you can see here, this is the generated report as Redact fitting database version 5 I am using, and today is Friday, and this fitting name is a straight duct rectangular. Number is CR11-1. Okay, and this is the input what I provided, I enter in the software. That is nothing but the height, width, and absolute roughness, length, and flow rate. Okay, and this output is given by calculated by software. That means this v is nothing but the velocity, and velocity pressure PV. Okay, 8 pascal, and friction factor is 0.017, pressure loss is 0.6 pascal. So you can save this, and you can attach with your report. Okay, so for the go to the next fitting. Next fitting is also your straight duct. So for the straight duct, similarly I am going to calculate 1000. The duct size is same, only the length is going to be changed here, and the airflow. So let me check the length from here to here, 670. That means here third, tag number third, straight duct size will be same, and length is 0.6 meter. Okay, 0.65, 0.6 meter, and flow rate is 1601 liter per second. That means, why 1601? This sorry, 50 CFM is here, so convert into liter per second. 2.119 divide, so 23. So 1651 minus 23, 1628. So airflow is 1628, and the pressure loss, simply enter this value, and 0.65 meter, and 1628 liter per second. Simply click on calculate. So I am getting a 0.1 Pascal. So simply enter a 0.1 Pascal. Okay. So similarly, I have to calculate. So similarly, we have to calculate for all these fitting up to this last terminal. So we will continue in the next class, because the video will be going to be too high, too big. So we have to calculate to in the next class again for this another fittings. So I hope you guys learn how to calculate the pressure loss, ESP calculation or pressure loss in the duct and fitting. So we will continue guys in the next tutorial. So thank you for watching my video. Thank you for watching my video. Thank you. Thank you. Bye bye.